Hello once again. In this video we are going to focus on the synthesis of peptides. Now we mentioned before that peptides are formed when we have amino acids interacting. So assuming we want to form a dipeptide, we can have alanine and glycine. When we have these two reacting, they can form a peptide bond where the alanine comes first, then glycine. Another option is we can have glycine coming first and reacting with the alanine to form glycine being the first one. So in other words, if we just do this reaction the way it is, it's going to be chaotic. We're going to form a mixture of products which is not something we want to do. So how then do we do this reaction? Well, the best way is to protect the N side and also protect the C side. That is the C terminus and the N terminus. Then only leave the ones that we want to interact to be free to do a reaction. Now once we do that, then we can bring in DCC. So here we use DCC coupling to form the peptide bond between the amine and the carboxylic acid. So in other words, if we want to form the product, we have to start with protecting the amine, the side we don't want to interact. Then we also protect the carboxylic acid, so only the ones that are free are going to react. Then we introduce DCC to couple those two so we form the peptide bond. Now, what are the methods by which we can do protection of either the amine or the carboxylic acid? There are two methods by which we can protect amine. We can use what is commonly called the bulk protection. In the bulk protection, we use di-tert-butyl dicarbonate. When we use this portion, the amine is going to attack the carbonyl, and later on it's going to kick out that other portion. So we end up with what is called the bulk protecting group. So the amine is now protected by bulk. So that's why we call it bulk protection. So now only the acid side is left to do a reaction. If you want to do deprotection, because whenever we do protection, we have to think of how are we going to do deprotection. The deprotection of this group can be done using what is called trifluoroacetic acid, commonly called TFA. So trifluoroacetic acid can easily do the deprotection. It kicks out the bulk group and it regenerates the amine. Because it's an acid, it's going to regenerate it as ammonium ion, which if we want to use a base, we can to transform it into amine. Another method we could use is called the FMOC protection. In FMOC protection, we use what is called 9-fluorenyl methyl chloroformate. When we have an amine, it's going to interact in the same fashion like it did with bulk, and we end up installing the FMOC protecting group. For FMOC protecting group, the deprotection requires the use of a base, so the direct opposite of what we did with bulk. So here we use a base to do deprotection. For bulk, we use trifluoroacetic acid to do deprotection. When you do this deprotection of FMOC, we end up with a product that we're interested in and another byproduct. So in other words, this requires further purification. So most people prefer to use bulk protection because when we use TFA to do the protection, it usually gives a higher yield. There's quantitative yield, and sometimes, or in most cases, there's no further purification after the process is done. So most people prefer the use of BOC and then TFA protection due to no side product being formed in the reaction mixture. For carboxylic acids, we can do protection by transforming them into an ester. Now we can achieve this using Fischer esterification. So we use an alcohol in the presence of an acid, that is the carboxylic acid, and we also need something like sulfuric acid, so that is the one over here. So sulfuric acid and heat. The reaction usually requires heat. And then we transform it into an ester. Now we can also hydrolyze this compound to transform it back into carboxylic acid. The hydrolysis can be achieved either using a base or we can use an acid, whichever is convenient. Okay. Sometimes when we form benzyl esters, then the deprotection can be achieved using hydrogen palladium or even the use of acetic acid in the presence of bromic acid. That can help us to do the deprotection. So in summary, if we want to synthesize a peptide, for example, the phenyl, or in this case phenylalanine and valine, then the first thing we need to do is figure out which one do we want to come first. If we want phenylalanine to be the first one followed by valine, then the first thing we do is we protect the amine of the phenylalanine so that we only have the carboxylic acid being free to react with the amine of the valine. Then we also need to make sure we protect the acid of the valine. When we do that, now we can be able to do the reaction. So we take that, mix it with the ester, protected carboxylic acid, then we incorporate DCC to do the coupling, then we end up with the intermediate. Once we have the intermediate, we can now do deprotection. So if we want to deprotect BOC, we use TFA, that is trifluoroacetic acid, TFA, and that deprotects BOC. And then if we want to do the hydrolysis of the ester, we can use base hydrolysis so that we end up forming the product. Thank you for watching.